Hello, everyone. Thank you for joining this session. Just a couple of reminders before we begin. Make sure you have the app downloaded on your phone so you can organize your schedule for the day, and you can submit your feedback for the session. At the end of the session, you can scan your badge at the door to get the content right afterwards. At this time, I would like to welcome to the stage Steve Sofian, who will be presenting on best practices for migrating your Microsoft workloads to AWS.
Thank you. All right, thank you for coming to this session on migrating workloads to AWS. So in this session, the focus is on migrating Microsoft workloads, custom applications to AWS. This is a high-level, 300-level session. I'm going to give you a holistic view of migrating applications onto AWS when there is a need to dive deeper into certain areas that has more focus in terms of the different workloads. We'll dive deeper. There's a lot of content to be covered. I have 30 minutes to do it. So there is a website called unicornshop.lol. So there's a lot of content and links provided in there just in case you want to dive in further and get more content on this session. So we are going to cover some landing zone. What are the common so-called shared services around your workloads that you can use across AWS accounts, across multiple VPCs, as well as how do you build a repeatable architectures. So why are departments choosing AWS? So I want to debunk the myth that Microsoft workloads run better on the other CSPs. We have been doing this for almost 11 years now. We are the first cloud service provider that actually deploy Microsoft Windows onto the cloud. We have a global reach of about 22 regions and more than 66 availability zones. All our services is security compliance, and we are customer obsessed. Since 2006, we have launched about 670 plus services. And 90% of those services is basically based on customer feedback. And we are able to deliver up to 80,000 IOPS per instance. This is very critical when you're running enterprise workloads. And over time, we are able to help customers to lower their total cost of ownership by reducing price for almost 72 times. So since 2008, we launched our first Microsoft Windows Server 2003 and SQL Server 2005. And over the years, we are supporting the end of life of Microsoft Windows Server 2003, SQL 2005, and SQL 2008. As you can see, for the past 11 years, we have kept continuing to innovate on Microsoft Windows. Microsoft Windows is actually a first-class citizen in AWS. So in 2012, we actually launched RDS for SQL Server. And in 2012, that is the only time that Azure started to ramp up on the cloud. And as of May 2008, we have launched about 26 features on Microsoft Windows alone, from supporting SQL Server on Linux, .NET Core support on Lambda, Code Build, Elastic Beanstalk. So how about my developers? My developers have been using the same tools with Visual Studio, with NuGet packages, with PowerShell, command line, and also Visual Studio Teams services. Well, we actually have those tools killed as well. So we have a toolkit for Visual Studio as well as Visual Studio Code. We have .NET SDK that allows you to get all the packages that is on the NuGet marketplace. We have tools for PowerShell. We have command line interface as well as Visual Studio toolkit for VSTS. So why do customers or companies think before migrating their Windows applications? So first of all, we believe looking at the network design, right? So this is granted. This is the most basic system design that you have virtual private cloud, you have some local connectivity, and also on-premise connectivity. How do you define the subnets, the DMZs? How do you do centralized logging and monitoring? So this is granted. So what does every enterprise Microsoft service depend on? Right? Active Directory. With AWS service for Microsoft Active Directory, you can actually have a managed AD on AWS or even deploy AD on an EC2. And with that, you can actually do with or without forced cross-domain trust across the on-prem as such that your users will be able to still leverage on your existing user AD credentials to log into applications. And you bring your existing group policies to the cloud as well. So we have a Microsoft Managed AD on AWS. This is a full-featured enterprise AD. Right? So as a start, I want to do a forest trust with on-prem as such that I want to give a seamless user experience to my users as such that they use their local credentials to log into applications. And with that, I can have a domain join of Amazon Linux instances or Microsoft Windows instances automatically joined to the domain. And with that, I will extend it to those AD-aware workloads like SharePoint, Exchange, your SQL Server, or even your custom applications. And on top of that, there's a lot of AWS services that leverage on this particular AD as well, right? So we have Microsoft Workspaces, with WorkDocs, WorkMail, WorkSuite. All those can leverage on the managed AD for authentication. So how about third-party SaaS applications? Well, you can actually use AD Connect or AD Sync to synchronize your users with Azure AD. And at the same time, using ADFS to provide SAML federation to Office 365. This will give your user a seamless experience using SSO to those SaaS applications. So how about if I want to migrate my AD? I want to go all in on AWS. So I want to actually migrate my whole AD onto a Microsoft Managed AD as such that I will deploy a Managed AD across 2 availability zones. I have 2 domain controllers on AWS. I will create a domain client and connect it to the Managed AD itself. And with that, I will deploy ADMT, the Active Directory Migration tool, as well as the PES, the Password Export Server, on the on-prem AD. As such, I have a connectivity to the domain client as well. And with that, I'm able to migrate everything from the existing on-prem AD onto Microsoft Managed AD. So with that, taking care of the AD itself, now we can come up with a sample reference architecture for Microsoft Windows workload. So I have Microsoft AD on Managed AD on 2 AZs. I have SQL Server, I have Web Server, I have Remote Desktop Gateway to provide a jump box to those Windows Server instances. I have a private connection to on-prem as such that for sensitive data that is still required to reside on-prem, I have backend integration to those data. So how about SQL Server on AWS? What are the options do I have on AWS? So we have 2 options here. One is Amazon Relational Database Service, RDS. This is a managed database service that you can actually leverage on without having taken care of the OS itself. The patching, the backup, the snapshots is all taken care for you. Or if you want to have full control of the instance of the SQL Server, you can deploy SQL Server on Amazon EC2 as such that you will self-manage, you have full control, you have full access to the operating system. So what's the difference between these 2? So as you can see, on Amazon EC2, you have to bring your own, the license is included, or you can bring your own license. There are 2 options here. You have full control over the instance. You can have access to the OS level data. You have to manage your own AZ in terms of having the SQL Server always on across the 2 AZs. But of course, with RDS, everything is included. You have automated backups. You can deploy multi-AZ automatically. So how about storage? For database, especially SQL Server, your disk basically is your bottleneck. So the storage I/O contention is one of the main causes of poor SQL Server performance. So how do you want to structure your disk storage in terms of cost optimization? You want to use AWS optimized instances as such that give you the best throughput to the disk itself. You want to match your storage technology with the I/O patterns. So for example, here I have a sample volume layout here. My Windows and my SQL Server running on a C drive, running on GP2 SSD. And my most critical disk basically is my data and my transaction logs will reside on a provisioned IOPS disk. That will give you a consistent IOPS to the disk. You can specify the number of IOPS that you need anytime you want. You can change it anytime you want. And for backups, because I do not need a very high throughput disk, I can run on a cold hard disk. And lastly, TimeDB, which is one of the key in terms of contention for the storage, because when you do SQL query, a lot of joins, it requires TimeDB, and it will come and go. So what you want to do, basically, you can want to leverage on the instant store. Instant store basically is a disk that resides physically on the physical hardware. As such, it gives you the highest throughput to the disk. So how about migration? So we support the traditional migration of SQL Server from backup and restore, bulk copy, log shipping. So what you can do is all the key differences is the different downtime that you will face. So depending on how much downtime you are able to tolerate, you will choose the different patterns. But of course, we have something called AWS Database Migration Service. This allows you to do real-time migration, copying the data, the schema, the objects, the indexes, everything to Amazon RDS or to Amazon EC2. At the same time, should you want to migrate to a different database engine, within DMS, it has something called SCT, the schema conversion tool. As such, it allows you to change the schema to match to another database engine. So for example, I want to migrate SQL Server to MySQL. I can leverage on SCT to do that conversion for me. So how do you do the leverage on DMS? First of all, you launch a replication instance on DMS. You will connect to the source, connect to the target. You select the tables, the schemas, or the number of databases that you want to sync across. And with that, database migration service will automatically sync the data from one source to the other target. And once you're done, you can switch the application to point to the new database once you're comfortable with that database. So there are many ways to move data onto AWS. One is from a network perspective, where you copy data over the network. We provide you with Direct Connect, which is a private list circuit that you can pull from your data center onto AWS. You have S3 transfer, you have EFS faulting. All these are data transfer over the network. But what if you have huge amount of data, like terabytes, petabytes, or even exabytes? So we provide you with a different methods of transferring data as such that we'll ship devices to you. You copy the data onto the devices, and you ship it back to us. So one way is basically the AWS Snow family. So in Singapore region itself, we do have Snowball and Snowball Edge. These are so-called tamper-proof devices as such that you can copy data. All the data is being encrypted using your KMS keys. The keys does not reside on the device itself. So once the device is being shipped back to AWS, we'll copy the data onto S3, and you leverage on your KMS keys to decrypt the data itself. So how about application migration? So there are three options here. So one is bring your own VMs. You could be running a VMware or Hyper-V on-prem, or you have certain containers that you have developed. So when you bring your VM, we have a service called Server Migration Service. As such, you deploy a connector onto your on-prem, is either on Hyper-V or vSphere, as such that you start replicating the data into AWS as an Amazon machine image. Next, you want to bring a container, or you have to deploy your code onto a new container. So you can actually store the images on Amazon ECR, and subsequently using CloudFormation to deploy those applications, and you are able to do a blue-green deployment or A/B testing on this environment. Next will be custom applications that you want to build. You start to look at serverless architectures as such that you want to refactor an existing applications to leverage on Lambda or API gateway, or deploy it using SAM, which is a serverless application model. So let's say, for example, you have a COTS apps. You have a custom app that you have, the fastest way to actually to rehost. So what it does basically, from the existing VM that you have, it will copy there's no agent to install on your VM. What it does basically, it will take the disk, it start replicating it, and creating an Amazon machine image onto AWS. What if you have microservices? You have REST APIs, you have containers. You can actually use code, publish those containers onto ECR, and using code pipeline, code deploy to deploy onto a microservice architecture. Lastly, you want to refactor applications as such that you want to leverage on cloud-native services like Lambda, API Gateway, ECS, or EKS. So let's say we are going to rehost a server applications. So for example, here I have a web app running on vSphere. I deploy the SMS connector onto the vSphere itself. The server migration service, what it does basically, it continuously copying the data and generating Amazon machine image on the cloud. And with that, you can actually deploy those AMIs as EC2 instance. So what are the strategies for migrating .NET applications? So you can deploy your .NET framework as is onto EC2. Basically, you're deploying your code on creating a server VM with Microsoft Windows instance on it, and you can have different .NET framework installed on the EC2. You have multiple EC2s. Or you can basically start to containerize your Windows applications and leverage your ECS, which support Windows containers. Or you can port your whole application to a new .NET framework called .NET Core. As such, that you can run on Linux, on ECS, or Fargate on Linux. With that, there's no OS licensing cost, because you take that piece away. You can enable your apps to be deployed as a Lambda functions as well. So how about containers? ECS is Amazon Elastic Container Service. This is a managed container engine, orchestration engine that you can leverage on. So your existing developers using Visual Studio can leverage on the toolkit for Visual Studio as such that you pump the code into code commit, which is your private GitHub repository. You can test the development code using code pipeline. You can define the stages as such that I want to do a unit test, a load test, a stress test on the applications. And once that passes, it will go to a code build, which starts to build the container itself. So once that container is built, it will go to ECR. And with that, you can actually leverage on CloudFormation, which is template infrastructure as code, to deploy ECS and subsequently deploy your container onto ECS itself. So how about Windows file servers? I'm going to all in onto AWS, but I still have a lot of file shares on-prem. So how do I move those data that's residing on Windows file servers onto AWS? We have a service called File Gateway as such that it's a server VM. It exposes itself as SMB or NFS protocol. With that, all the data that is copied onto this file share will automatically move to S3, and there's a local cache copy being stored on the File Gateway itself. All the ownership, the permissions, and the timestamp are preserved in the S3 user metadata service. So now we have a CMS, which is very common web app database. We have a batch job server as such that sequentially overnight, I will start to run this cron job to start copying data, for example. This is very common. But look at it, it's that this cron job doesn't run all the time. You're having a server that is sitting there for 24/7, and potentially it only runs like 2 hours every night. So how do I refactor that using AWS Lambda? So for example, that batch job is copying data that is files that is uploaded by vendors. You are doing some ETL, reading the file, and updating the database. So with that, instead of having to run it overnight or as a batch mode, you can actually have an event-triggered function as such that anytime a file is dropped onto S3, it will trigger a Lambda functions, look at the file, and start updating your database immediately. Right. So the key thing about building repeatable architecture is about automations. We have a service called AWS CloudFormation as such that you can actually define the whole a Windows stack from web app DB as code. You can use version control on that template because now not only you have version control on your software, on your application code, you have version control on your infrastructure as well. And with that, you can actually deploy the same stack again and again for development, testing, and production. Because quite often, we have disparate configuration among the different environments because everything is done by human. So it's error prone. So if the infrastructure as a template, now we can build a repeatable architecture of the same stack again and again. So I move my application to the cloud. I want to leverage on as much as possible the cloud-native services. So to protect my application, I still need a web application firewall. So I can leverage on AWS WAF with managed rule set from our vendors. For the different type of applications, the different type of rule sets that's provided by these vendors. So now with all in on AWS, I have a portfolio of applications from regulatory app, from batch jobs, as such I'm leveraging on EC2 auto-scaling to allow me to provide a highly scalable applications now. I'm leveraging on AWS Lambda as such that I can run event-triggered functions as anytime I want. For those third-party COTS app, you can actually leverage on the multi-AZ as such that you improve your high availability. And lastly, microservices, you can leverage on ECR, ECS, or EKS to run your containers. So finance the architecture is something that looks like this. So on the top portion basically is your applications. On below, what you see is a whole set of suite of services that you can leverage on, from security, certificate management, configuration and system configuration, storage, monitoring, and DevOps. Those are the native services they can leverage on to build your applications. So next, once you have deployed onto AWS, you need to operate. And to operate, automation is key. Quite often than not, we are always looking at WSUS to update Windows patches, to create golden AMI, or golden images per se, and start to update your applications, redeploy the code as such that you're patching your Windows environment. On AWS, there's something called System Manager. System Manager allows you to automate this process automatically. So what I have an existing instance. I'll create a temporary instance from that instance itself, start updating whatever EC2 config, drivers, and even custom user application code. As such that I run a sysprep, very typical for Microsoft Windows, as such that an instance can be redeployed and reused. Once it is done, I'll stop the temporary instance, and I have a brand new Amazon machine image with all the patches being updated. And I'm now ready to deploy the applications. So with Windows environment, to manage it, we always require RDP. And to do RDP, as you know, as much as possible, we want to help customers to safeguard and secure the environment. Instead of having to go to a remote desktop gateway host, having the key pair, having a username and password to log into those systems. Now, you can actually leverage on something called Session Manager. You have actually shell access to the Windows environment without having any key pair. You just go to the AWS console. So operating your cloud, there are multiple options here as well. As such, it can be self-managed. You can leverage on Systems Manager to manage and operate the environment. You can leverage on Service Catalog. They provide a catalog of approved IT services that your users can deploy. The modeling and provisioning, the automation and operations, and monitoring and logging with CloudWatch. We do have AWS managed services as well. This is a service that will help enterprise customers to manage the environment from the OS down. Okay, we do not manage the applications. It's only the OS down to the hypervisor. Unlike other MSPs, this is a month-to-month engagement, as such that you can actually engage us for 1 month and give us 30 days notice, and you can terminate that engagement. Of course, there are other partners, MSP as well, that you can leverage on. So you put it all together, you have a landing zone, you all leverage on CloudFormation, your server migration service, this is where you migrate your applications. You are leveraging on native security of virtual private cloud, guard duty, inspector, what have you, as well as on-prem integration with VPN gateway or direct connect. You are going to automate the golden image build process and have it run to inspector to do a VA assessment of that particular image, and then you will deploy those EC2 instances. You're going to leverage on CloudWatch and Secrets Manager to do logging and monitoring of your environment. You have detective and corrective controls as well, using guard duty, inspector, as well as Lambda to do automated remediation of the environment. And of course, the whole suite of security management tools, leveraging on Systems Manager to manage those environments. So in summary, basically, you can migrate your Active Directory, your SQL Server, custom.NET application onto AWS fairly simply with minimal downtime. You're going to leverage on multiple AAZs for HA. You're going to leverage on server migration service and database migration service to easily migrate your server VM and database onto AWS. You're going to leverage on ECS for containerized .NET applications. You're going to leverage on Lambda serverless functions to have event-triggered functions. Leverage on licensing options and using the cloud-native tools like System Manager to operate and manage the environment. But of course, there are other tools that can help you as well. We do have an AWS Migration Hub to help you track all the different server migration that is going on. We do have Cloud Endure as well that allows you to help you to migrate Windows environment to AWS. We provide you all the network data transfer options that you can leverage on. So with that, I got 8 minutes to give you a quick demo. Okay. Just give me a minute. Okay, so what I have here is Systems Manager. One of the key things I mentioned earlier on about having a live without RDP, not going to a bastion host, shutting down instance without releasing key pairs. So for example here, I have a session manager. There's no sessions running. What I can do, basically, I can start a session. And I have 2 different environments. One is Linux, one is Windows. Since it's a Windows session, I go for the Windows one. I can start a session. As you can see, I'm in the server itself. I give me a PowerShell environment. As such, for example, here, I want to find if any IS has been configured on this machine, on this server at all. So as you can see, there's no need for me to RDP. There's no need for me to SSH. And I can further show you that it actually strengthens the security posture of the EC2. Because there's not a single port that is open. So for example here, I have access some Windows. I can see the security groups that is for these instances. As you can see, I have RDP there. I can even remove it and save it. And it will still run. So as you can see, I'm accessing the instance without having a single port that is being opened at all. Everything is just leveraged on IAM policies, whether you have permission to manage this instance, or even RDP, or so-called to go in through this session manager. Everything is through the IAM policies. And apart from that, in System Manager, I'm able to do patching as well. So there's a few predefined baselines that you can leverage on for Linux, for Windows. As such, you can leverage on. So let's say, configure patching. I can select the instances manually. I want to have a Windows. I can skip scheduling because I want to patch the instance immediately. I can scan only to see whether it's compliant with the baseline, or I want to scan and install. So with that, so the manager will leverage on run command, and using certain automation documents, will start to go and patch that particular Windows instance. You can manage those instances through SSM as well. So for example, here I have a Windows environment that I'm being managed. As such, I can see the inventory. Let's go to the other one. I have a Linux machine. So the inventory, it allows you to collect information on the system itself, whether it's applications, your registry, files. So with that, on the Linux machine, I can see these are the different packages that's running on the Linux machines. I can see what are the patches that's installed, and what are the configuration compliance as well. So based on certain patch baseline that I created, I have certain patches. I will show that how many resources does not comply with the patch baseline. All right. So, okay, so with that, let's go back to the slide. This is a quick one to give you a flavor of how you can leverage on Systems Manager to fully manage your environment. There are certain automation documents that you can leverage on, all the way from let me see. So you can want to do execute automation with this patching. You can even do instance management to create instance as such. It automatically be managed inside SSM. I can have a create image, create managed Linux instance, all the stuff, right? So with that, yeah, can we switch back to the slide? Okay. So the key takeaway here, basically, you can continue to use your familiar tool on AWS, your Visual Studio, your VSTS, your SQL Server Management Studio. Start small and be iterative. This is the key thing about moving to the cloud, is to give you that agility. And try to automate as much as you can. Start small, start with a simple CloudFormation template, start writing simple Lambda functions, leverage on some AWS config, start writing some Lambda functions to do certain remediation, leverage on managed services as much as possible, because it will take a lot of heavy lifting away from you as such to manage the operating system, manage the backups, all the stuff, and leverage on the partner community as well as the marketplace. We have 3,000 over ISVs within the marketplace with all the products in there. It's a one-click deployment. It will help to save you could be on procurement, on deployment as well. These are some of the resources you can leverage on. We have a whole suite of Microsoft Quick Start on AWS from a whole template of SharePoint 2016. As such, it's a one-click, you deploy the whole environment from SQL Server, AD, Remote Desktop Gateway, NAT Gateway, your search server, your front end, your application server. So with that, I hope that is much useful to you for attending session, and please complete the session feedback. Thank you.
Thank you very much, Steve. So again, a reminder to complete the feedback in the app after this session. Our content team will now be standing at the front of the room. So if you would like the content right after the session, you can make your way up to the front and scan your badge. At this time, we'll be getting this room ready for the keynote. So we will ask that everyone clears out of the